We do have to get to our next panel, which is Marine Technology, the bridge between defense and commercial opportunities. And Lee, I am going to pass it over to you right now so that you can kick it off and introduce everyone.
So we have 30 minutes. We're going to touch upon various topics. You're going to hear each of our speakers, and I'll introduce them in the order they're going to be speaking very quickly, but it's going to be a snippet. So I encourage you to contact us directly with questions or put them in the chat room. What we can't address on this call, we'll address connecting with you one-on-one. So we have George Dossot here today, Director of Science and Technology for NUWC Code 15, Sensors and Sonar Systems. He is a brilliant engineer there, engineer scientist, and he will be talking about not just marine technology at NUWC, but those things that have a relevance to offshore wind. He'll touch at a very high level on that. Next will be Dr. Peter Chomowicz, who is from General Dynamics Electric Boat. He is a leader in General Dynamics, and his tagline basically is concepts to capability. So that kind of explains it all. So Peter will talk about, from the perspective of a commercial company, the technologies that they see could be or are relevant to the offshore wind arena that they have anchored in their DoD applications or vice versa. We're going to be followed by George Nickolopoulos, who, while many of you might know him as the URI outreach liaison, he was at every table that you can imagine in the state representing URI. Most recently, he went to Goetz Technology, Goetz Composites, and he will be talking about, you remember the discussion starts with DoD, goes to DoD to commercial with a large DoD prime contractor, on to Goetz, and George, who will talk about from the concept or the perspective of a company that houses phenomenally interesting technology and the potential application into the offshore wind arena from their specific technology vantage point. Then we're going to move on to Christian Cowan, who is, as I mentioned in the beginning, the 401 Tech Bridge Director, as well as Executive Director, as well as the Executive Director of Polaris MEP. He will talk about now anchoring himself, his perspective on the commercial side, the economic development, job creation side, looking at technologies that have potential to be acted upon relative to offshore wind or partnering or matchmaking, you name it. And then we're going to wrap up the discussion with Steve Bordonaro, who not only is a respected scientist at the Naval Undersea Warfare Center, one of the senior leaders there, but also the director of the Northeast, coming out of the National DoD Initiative, the Northeast Tech Bridge Director. And he will talk about enabling services, enabling capabilities that we have in the state to make these connections and to help businesses and small businesses get their technology seen and heard. So with that, please, George Dossot, if you could kick it off for us.
Great, Lee. Thanks for the kind introduction. Can you hear me? Give me a thumbs up. Yeah, good. Okay. So yeah, I'm really happy to be here and share basically my personal perspective of where the overlap is between what we do inside the gates at NUWC and how we can engage with the offshore wind community. So just real quick, if people aren't aware, NUWC, Undersea Warfare Center, we traditionally are thought to deal with the systems that go within submarines, but there's a broader aspect to what we do. Undersea vehicles, any kind of technologies and systems that essentially support maritime applications. And we work across different warfare centers throughout the Navy. So I say that because there's a lot of potential overlap between offshore wind and what we do within the gates at NUWC. So I think the important way to phrase the overall discussion is we can ask, what is the R&D that's motivated by defense applications? How can that be basically tailored to offshore wind, and vice versa? What is the R&D that has been motivated by offshore wind that can potentially be useful for defense applications? So really, when you tear it down, it really comes down to what are the enabling lower level technologies that can be applied to the different problem spaces. So just for some examples, within the gates of NUWC, we have high interests in materials research. So just kind of spitballing the technology that could be used for an underwater vehicle skin could definitely be viable for the piling or the fins that drive offshore wind. My personal expertise and interests deal with acoustics, undersea acoustics. So I am personally interested to understand, has there been any quieting technologies that have been applied to the offshore wind problem space? Because what happens is the vibrations couple into the ocean as acoustic energy. And that's important from a defense perspective, because one man's noise is another man's treasure or another man's problem. And it's also important for marine stewardship. We want to make sure that we don't create noise pollution for environmental purposes or problems. There's some other things that happen at NUWC that are relevant to the offshore wind problem space, which is environmental permitting. We do a variety of processes and the scientific support to look at acoustic propagation modeling that could be applicable to things like the pile driving that is necessary to often install these offshore wind turbines. That creates a lot of noise, which can be problematic, and there's ways to mitigate that. Also, from an infrastructure perspective, you know, the infrastructure, the surveying, and the moorings, the cables that are required to support offshore wind, they have other applications the Navy could be interested in. So there's dual use from that perspective as well. And you know, I'm just going to throw this out there. The Navy has basically ownership or supervision over, you know, many square miles of ocean for naval range purposes. And there could be an opportunity for those sites to be viable for offshore wind. On the other hand, they may not be, just because they primarily serve the purpose, you know, for defense. So having a wind farm in a Navy range may not be appropriate. It might actually be problematic, but you want to basically open up the question to see if it can be used for that space. So I'd kind of like to caveat all my remarks with the fact that, you know, it's my personal perspective. It's not Navy policy or the message that is blessed. But after, you know, being in NUWC for several years, I've had my eyes open to a variety of R&D spaces that there's definitely dual use. And I think opportunities such as this can allow the collaborations to take place. And I urge you to listen to Steve's talk at the end, because he'll talk about some of the different mechanisms for outside industry, academia, and other organizations to engage the government, especially if there's definitely good ideas where we can work together. And I think that's all I have, Lee. Thank you very much.
Yeah, George, thank you so much. We get into whole discussions. We just don't have the time. So let's move on to Dr. Chomowicz, Peter from General Dynamic Electric Boat. Thank you, Peter.
Thanks, Lee. Everybody hear me? Thumbs up? Yeah, good, fantastic. Well, pleasure to meet all of you. So just a tiny bit of background. So I lead the company's external R&D partnerships, particularly with universities and supporting the small business environment. And I just want to make one comment that, you know, we're a big company, Electric Boat. Those of you that don't know, we're the only other company in the US that builds, designs, engineers nuclear submarines. So we make one product for one customer. And we rely extremely heavily on the small business world. So I'm particularly thrilled to be part of this consortium today. And I just want to emphasize that as an integrator of technologies, we need you. We need your innovation and your collaboration and participation to make our products ever better, particularly in the age of great power competition that we all know we're in. So I've grouped my comments on this topic into sort of three broad areas: materials, manufacturing, and actual components that we see can be of dual use or dual purpose between offshore wind, defense industry, particularly from an electric boat submarine perspective. When Lee first asked me to talk on this, I thought, well, you know, offshore wind's not my thing. I don't really know a lot about it, except when I go fishing out near Block Island. And I thought, well, you know, what does a submarine and offshore wind have in common other than being a really big steel tube with a propeller on one end that sits out in the seawater. Well, there's actually a lot in common the more I kind of thought about it and talked to my colleagues. And I'll give you my punchline right up front for these categories that I want to talk about, and that's maintenance and modernization. So when we take a submarine out of mission and we put it in dry dock, it's not doing what it's designed to do. And it costs an enormous amount of money. And I imagine exactly the same is true for offshore wind. That if you've got to stop a spinning blade that's hundreds of feet in diameter because you got to fix it, it's not only costing a lot of money in downtime, but in the maintenance. So much of what my laundry list of ideas here revolves around that one central theme, which is predictive maintenance. So how to keep our products functioning in a very, very harsh and unforgiving environment, the ocean. So just to kind of, again, a laundry list here. Under the materials category, I think things related to coatings. So anything that's anti-corrosion, biofouling, those are of particular interest to us in the submarine community. Metallurgy, steel alloys, and composites. Composites. We've got George here on the line, so good to see you, George. He's my go-to composite guy in Rhode Island. There is an enormous interest in composites from all kinds of undersea platforms, not just submarines, but we heard a minute ago from George, things like UUVs, smaller kinds of vehicles in the marine domain. Also propellers, right? I imagine the stresses on an offshore wind propeller are enormous, given their diameter, functioning in the midst of a hurricane or a gale force wind. The same is true for marine propellers, right? So we've got to deal with corrosion. We have to deal with enormous stresses. So how to keep them lightweight, how to keep them stiff, and reduce, again, the maintenance on something like a propeller. So the use of composites in all of those opportunities. In the manufacturing category, I put sort of first at my list rapid prototyping and additive manufacturing. So anyone working in that kind of space, enormous opportunity for dual use technology. That's both shipboard, those would be additive manufactured components for submarines or for naval and defense applications, but also what hard. So putting the actual manufacturing processes into a place like Electric Boat is critical, right? We don't make 3D printing, but we definitely need your help in figuring out how to integrate it into our manufacturing processes. Part and parcel to that is helping the Navy with a part qualification plan. So how do we get 3D printed, additive manufactured parts approved for naval use? Again, we need a lot of different businesses putting our heads together to crack that nut. It's very difficult. Robotics. That could be the assembly or sub-assembly of components using robotics. Also the manufacturing using robotic welding. So anyone working in that space. And then we have to stitch all this stuff together. You know, a submarine is roughly a million pieces put together in lots of different ways, 1 million pieces. So supply chain, logistics, all that kind of stuff. Yeah, absolutely. We need help. And I see a lot of dual use opportunity there. And also in terms of manufacturing, those of you that that might be working in more traditional, large scale industrial manufacturing, I certainly want to include you. You know, I sort of joked tongue in cheek earlier about a big metal tube sitting in seawater. Well, you know, it takes a lot of skill and ability to do that. So if you're working in metallurgy, handling large plate, steel alloy, working to high tolerances, bending, forming, how do we make these wind turbine stanchions, these tubes? I imagine it's maybe similar to the way we bend plate to make a submarine. Just guessing, but so a lot of opportunity there. So my last category is components, the actual things that I think that we are seeing or needing advances on in submarines that can and actually have come from wind energy. One of them was mentioned a moment ago by our colleague here, Eric Hines. and that's bearings. So roller bearings, ball bearings. There's a terrific company, an MIT spinoff that's produced hydrostatic round bearings that float in a cushion of oil, right? They're oil injected, and they can also actually float in water, not just oil. So if we think about predictive maintenance or the ability to reduce maintenance, if we can reduce the friction in a bearing, in a propeller shaft or in a key piece of machinery, the same way we can reduce the friction in a turbine generator, I think that we're going to be way ahead of the game. So this is my #1 topic for dual use conversion technology would be bearings. Right behind it would be hybrid propulsion. And I realize this is probably a bit more complex maybe than a lot of the small businesses in the area might be undertaking, but brushless motor generators in hybrid propulsion. We've already seen this in the wind turbine industry. There's a company out of Finland called The Switch that's looking at, not just looking at, but actually producing motor generators for use in ships and in turbines. So those are my 2 big component technologies. And then next in line, and this was mentioned also a moment ago, I know Lee's telling me, okay, my last one, Lee, sensors, right? So anything, so wireless, remote sensing, and the use of digital twin, AI, and machine learning for, again, for predictive maintenance. Thank you, I'm done. Back to you.
Peter, thank you. We knew this would be challenging because we could talk about this for the next 3 days and find opportunity. This is a wonderful matchmaking topic, but let's move on to George Nickolopoulos again, the perspective of Goetz Composites and the perspective of a small business.
Certainly. Lee, thanks so much. Everyone can hear me? Great. Well, it's such a pleasure to see all of you. There are a lot of wonderful faces out here on the screen that I haven't seen in a long time. It's nice to reconnect with you all, and I encourage you all to reach out to me directly if there's further conversation necessary after this. So yeah, Lee, this is the perfect dual use technology space for a small manufacturer like Goetz Composites. One of the things that I like to stress too about where I am now is that Goetz is not only a small manufacturer of composites, but we're a full systems engineering and integration company that's working in spaces that are both related to and relative to this technology area. What I find most exciting about the work that we're doing in the dual use technology space as it relates to defense and offshore wind is certainly our work in the undersea vehicle space. So we work in all 4 operational domains, from full ocean depth all the way up to a project that we will be deploying with NASA to the Jupiter moon of Europa here in the next couple of years, and everything in between. What we found is that the mission capabilities that we've been able to integrate into our unmanned vehicles that we've been building for our Navy partners are certainly applicable here to the unmanned, to the undersea requirements of maintenance, inspection, review, and maybe even some maintenance performance on these offshore wind systems, the cabling, et cetera. Not to mention deploying people to these spaces and some of the surface vehicles that we've built, electric powered foiling vehicles that we've built as well that use low energy and have high payload capacity to bring personnel out to these offshore sites. What we've found is that the offshore wind market for us is gigantic, that I agree with everything that everyone else has said, that it takes collaboration. We are an integrator and manufacturer of these vehicles on a small scale, but we don't make everything that goes on them. And we don't understand the mission set completely that everyone might need. So what we would do is invite those of you that are on this meeting, or those of you who know others, reach out to us, let us know what you need. We can build anything. One of the things that I'm really happy about representing Goetz Composites is that nothing that we build has ever been built before, which is what's so exciting about working there. Folks come to us with problems that are complicated and that don't currently have a solution, and we develop those solutions, manufacture that solution generally in incredibly fast time. And we're able to get those solutions out to our clients, performing in the field with an incredibly high performance rate. So please reach out to us. There are a number of different challenges that we think we could solve But we also think that those challenges are interesting and exciting, and we want to work with people to solve those together. So let us know. You know, some of you might think it'd be interesting for a composites guy to not be interested in blade manufacture and not be interested in blade repair. That's not really where we're at, right? There are companies that are doing that are fantastic at it. There are companies, 15, 16 companies just at CIC Providence, I think now, that work in that space. What we want to do is we want to solve those difficult challenges that exist in the engineering and design of vehicles that are related to the offshore wind area. And please don't hesitate to reach out to us when and if you want to collaborate. This is an exciting conversation. I love listening to our colleagues here, both from NUWC and EB, and I look forward to hearing from the rest of you. Lee, thanks for the opportunity. Tuni, big shout out to you, and I hope everyone has an awesome day.
Yeah, well, George, thank you so much. Only in the spirit of time will we move on very quickly to Christian Cowan, Executive Director, 401 Tech Bridge, as well as Polaris MEP. Christian.
Thanks, Lee. So for those of you who I haven't met, I am the Executive Director for 401 Tech Bridge. I have the great pleasure of working with Lee Silvestre every day, who is fantastic and an incredible resource to the state of Rhode Island. Very quick background, 401 Tech Bridge is a nonprofit that's focused on technology commercialization. It was the thought of this entity was started more than 3 years ago with Senator Whitehouse, who encouraged a few of us to start a composite center of excellence. That concept continued to morph of bringing people together into a facility where they could work on products and create the next generation of technology to be deployed out in the world. Luckily for us, we were introduced to the Office of Naval Research, actually by George Nickolopoulos. Thank you. So ONR sat down with us. We presented our concept of, by then it was a material center of excellence. And ONR said that's similar to this brand new tech bridge concept that we're developing. And then we were off to the races. So we are a nonprofit collaborative entity that gets funding from different sources. And we try to both find funding for projects and source project topics. However, Dr. Carlin from the Office of Naval Research in the very beginning said, we are very focused on dual use. That's come up a few times in this conversation. But I have worked in the high-tech manufacturing space for my whole career. And I can say definitively, it's very different to sell something into a Defense Department entity versus commercially. It's hard. So generally the Defense Department supports that activity, but we have competency to help companies find markets, find channels, find other partners to push those products out into the commercial world. So we have projects, active projects, funded projects going on right now with the University of Rhode Island and with the Department of Navy. We expect those projects to grow more and more. We have physical space that we're building out now in Portsmouth. And that physical space is lab-based, where people can come work together on technical projects. And then we will help them with go-to-market and commercialization activities, both in the Department of Defense and from a private commercialization standpoint. So we're here to help. Again, we're a nonprofit. Lee and I are two great contacts, and hopefully we can connect people and projects together to spark some activity.
Fantastic, Christian. And I would encourage everybody on the panel, if you're comfortable, please put your contact information in the chat room, because I think various people are capturing that. I know mine went up early in the discussion, but we're going to have our final panelist, Steve Bordonaro, who is the Northeast, coming out of Naval X, the Northeast Tech Bridge Director and Scientist at NUWC. Steve?
Thank you, Lee. So yes, I work at the Naval and Sea Warfare Center with George and others. And I also have the position of being the director of the Northeast Tech Bridge. So some of you may have heard of the Tech Bridge efforts that are going on with the Navy under an effort called Naval X. And what we're really trying to do with Naval X is improve how the Navy works with what we call non-traditional companies, small companies that don't usually work for the Department of Defense. And for many years, NUWC has been reaching out to companies and collaborating with companies in the region. You know, I see Valerie's on the line, and she does a good job at that, and Mary Sylvia has also done that. But what the recent change under Naval X, which I think is exciting, is working with the nonprofit hand in hand on the outside, which kind of frees us up a little bit to do some things you can't do as a government agency. So with that relationship, I think the partnering will be easier. I think it'll be more productive. And then the programming that's going to start for small companies, I think will be helpful also. So we're trying to set up programs for companies at all stages of development. We're working with Mass Challenge on acceleration programs for very early stages. There's a new way of funding companies called prize challenges, which is very open to people in a garage, to a small company. And then we have a lot of support for SBIR and STTR programs, as well as working with UTIC, the Undersea Consortium that supports prototyping contracts. In all these cases, taking advantage of dual-use technology, whether it comes from offshore wind or other industries, and bringing that into government use is something that's a real powerful way to increase the capabilities of defense, to get that technology in quickly. And then vice versa, there's a lot of expertise in patents, et cetera, that the Navy has, that we can have relationships to work together. We can do cooperative research with outside companies. We can license patents, et cetera. So we're very excited about bringing technology in from a dual use perspective, but also pushing technology out. And through the 401 Tech Bridge as that kind of glue between us and the commercial world, I think it's a really powerful combination. Thanks.
Steve, thank you. And certainly we can try to answer maybe a question or two, and I haven't seen questions, but I asked you to look at offshore wind as a really great intersection point where there are many opportunities for cross-technology applications, with common themes being innovation can come from anywhere. We should absolutely maintain the importance of looking for innovation in non-traditional spaces, and that fostering innovation and solving problems today and in our future is what a lot of our organizations are here to do, and facilitate that cross-exchange of ideas and applications. So I don't see any questions, and we're actually 1 minute ahead. I'm sorry for all the pressure on you folks who had so many more messages to share, and this could be so much richer a discussion, but don't hesitate to contact us directly. And I just thank you, Toonie and Amy, so much for organizing this.
Yeah, thank you, all of you. I would really love to see this become a larger discussion. I think it could be an 1.5 hour discussion easily, that would just captivate all of us. But you guys are amazing, and we really appreciate all the work you do, obviously, to keep the system going. We are going to shift now to our final session